Welcome back, friends. In the yesterday's session, we discussed about the temperature mole fluctuation phase diagram, and today we are going to continue with the behavior of ideal solution on distillation. Now, if you remember, in the yesterday's session, we discussed one thing, that the ideal solution, if we want to draw the temperature mole fluctuation phase diagram, we can draw as this y-axis is temperature, and then because you have two liquids in the solution, so we'll draw in this way, and then we'll have two liquids. Let's say here it's the boiling point, and this axis also is the boiling point. But here we may have liquid. Let's say it is liquid A, and here we may have liquid B, liquid A and liquid B. Now, say liquid A is more volatile. Let's assume liquid A is more volatile. If it is more volatile, that means it has a lower boiling point. And in this case, liquid B will be less volatile. And if it is less volatile, that means it has higher boiling point, less volatile and higher boiling point. Now from here, if liquid A has a lower boiling point, that means if we are labeling the boiling points, let's say here it is the TA, that is the boiling point of liquid A, and here it is TB, that is the boiling point of liquid B. Then the temperature mole fluctuation phase diagram will be like this way. That means here it is mole fluctuation of A from 0 to 1. Mole fluctuation of A from 0 to 1. This is the mole fluctuation of A, and here the mole fluctuation of B from 0 to 1. Mole fluctuation of B from 0 to 1. Mole fluctuation of B. Now, unaweza kuona kwamba you can observe one thing, kwamba as the temperature decreases, because this is the liquid phase, and then you will have the vapor phase, which we are drawing like this way. This is the liquid phase, and this is the vapor phase. So at any time, you can determine the concentration or the amount of the substance which exists as vapor. For example, if we are taking at this concentration, let's say at this concentration, let's call this concentration as C1. At this concentration C1, what will be observed is that we will have a lower concentration of we'll have a higher concentration of A in vapor phase. Why? It is because A has a lower boiling point. And if we have a higher concentration of A in vapor phase, that means we have a lower concentration of A in liquid phase. So let's assume this concentration of A it is 0.7. If it is 0.7, because it starts from 0 to 1. If it is 0.7 in A, that means this will be equivalent to 0.3 of B, because the mole fluctuation of A plus mole fluctuation of B, we must get the sum is equal to 1. So what is meant here is that the more volatile liquid is the one which will exist in vapor phase. More volatile. That means it requires small amount of temperature so as to exist as gas. More volatile liquid is the one which will exist as vapor at a lower temperature. So kama tukafanya distillation now, let's say tunazo hizi liquid mbili zetu tunazifanyia distillation. So tumeanza na temperature, tumeanza na liquid in composition fulani, tunafanya distillation. So assume, let I draw another graph here. I'm not using a ruler because I'm just doing this graph. So assume ni graph ile lakini sasa tunaweka B huku, tunaweka A huku for simplicity of explaining. Temperature A, then temperature B, boiling point au kuni boiling point. A is more volatile kama kawaida, so kutakuwa na liquid A na kutakuwa na liquid B, mole fraction of A huku itaanzia 0 itafika kule ni 1 huku 0. Hii ni mole fraction of A, na mole fraction of B itaanzia huku itakuja kuwa ni mole fraction of B, huku ni 1 huku ni 0. Hapa ni mole fraction of B. From there utakuta hapa kuna temperature B imeshuka mpaka pale, then kuna temperature tena. This is liquid phase, and this is vapor phase. So let's say we are starting with a solution with a certain mole fraction. Let's say the mole fraction of solution is this one. Na kama unavyoona, in this solution what will be observed ni kwamba mole fraction of B will be greater, kwa sababu huku mole fraction inaanzia huku ya B inakuja huku. So in this solution mole fraction of B will be greater than mole fraction of A. So in this case manake mole fraction ya B hapa itakuwaje? Itakuwa, let's say it is 0.7 and mole fraction of A will be 0.3 to get 1. So if we are doing distillation, remember tunafanya distillation, that means the more volatile liquid ndio ambayo itakuwa ina exist sana kwenye distillate. Kwa sababu tunafanya distillation, in fractional distillation, I drew the diagram yesterday showing the fractional distillation, and I explained what happens in fractional distillation. So let I find the paper which I used to draw the diagram yesterday. But what I want to tell you that in fractional distillation, let I draw again. I said yesterday that we have the round bottomed flask like this one, or the flat bottomed flask. Then here we may have a little stand. Then here we have the source of flame. Let's say it is the Bunsen burner, which is the commonest source of flame in the laboratory. So from here we have a liquid, or we have the mixture here. We are heating this mixture, and then the vapor tend to go upward. From there we'll have just like a funnel here, and here at the top we may have just a stopper which can prevent the escape of vapor. So but this one is covered by this tube is covered by the water tap which tend to supply water. So kuna cover nje. Hii cover inakuwa na water in, cold water in, then kuna water out. So hii water in na water out inasaidia kupoza. Huku ikitoka inakuwa nini? Ni vapor. Na remember this vapor inakuwa na nini? Ina kitu tunakiita vapor composition. In liquid tunakuwa tuna mole fraction. Lakini huku tunakuwa na vapor composition. And remember, in vapor composition, more volatile liquid will have higher vapor composition regardless of it is more fraction. So hii more volatile liquid hata kama humu ndani iko chache, lakini ndio ambayo ita exist nyingi kule kwenye vapor. So what we are saying ni kwamba kutokea hapa itapanda, huku vapor itaenda ita condense, huku tuta collect kitu tunakiita distillate at the collector. So collector, let's say our collector is the conical flask. Our collector is conical flask. Kwa hiyo kama collector yetu ni conical flask, that means huku zitakuwa zinafika kama drops. Zimeshafanya condensation hapo zinashuka kama nini? Kama drops. So hii liquid tunaita jina lake distillate. Na hichi chombo ambacho tuna collect huku tunaita collector. So the distillate will be found in the collector. So the composition of distillate, composition of distillate is the same as the composition of distillate is the same as the composition of vapor. So kama hapa tuko na kitu kinaitwa vapor composition, pia composition ya hii distillate itakuwa sasa na ile nini ya vapor. So hii tunaita kama ni first vapor au tunaita first, ukiita first distillate, first vapor. Kwa hii distillate, remember nimekwambia kwamba vapor itakuwa na nini, ina composition kubwa ya more volatile liquid. Pia hii distillate inakuwa na composition kubwa ya more volatile liquid. So what we are saying that on successive distillation and condensation, what will happen? More volatile liquid will be collected as a distillate in the collector, and less volatile liquid will be left as a residue in the distillation flask. So on a successive distillation and condensation, yani tunavyo evaporate tuna condense, baadaye kwa sababu hapa nimesema ina high concentration more volatile liquid, so baadaye tutapata more volatile liquid yote itakuwa kama distillate, less volatile liquid itakuwa left as residue, lakini sio distillation moja, ni nyingi. So in a graphical presentation of this, we are saying kwamba tunaweza tumeanza na mole fraction fulani hapa, ambayo mole fraction inaweza ikawa labda hapa ni 0.7 ya B na 0.3 ya A. Lakini remember tumerate A yawe more volatile, ndio maana temperature yake boiling point ndogo kuliko boiling point ya B. Kwa hii tukiboili tutapeleka hivi mpaka hapa. Hii itakuwa nini? Ni vapor. So tukiboili mara ya kwanza itakuwa ni vapor. Sasa hii vapor tukifanyia condensation hii vapor, tukaikool, tutapata liquid fulani hapa. Lakini hii liquid itakuwa na mole fraction fulani hapa. Now look at this mole fraction. Let's call this concentration is 1 and then this is concentration is 2. Look at this mole fraction. Utaona nini? A imeongezeka, B imepungua. So let's say A here is 0.6 and B is 0.4. Tunalete tu. From there, if we boil again this liquid, tutaenda hivi. This will be our second vapor. Hii tunaweza kuita kama ni first vapor. Hii itakuwa ni ngapi? Ni second vapor. Tukiboil tutafika hapa kwenye second vapor. Second vapor tukicondense tutafika pale kwenye distillate ya pili. Lakini hapo ukija kuangalia tena unakuja kwa nani? A hapo unakuja kuona imeongezeka zaidi. So let's say here A is 0.9 while B is 0.1 kwenye second vapor. Tukiboil tena hapo unakuja kuona kabisa tunafika kwenye point ambayo A inakuwa ni 1. So hiyo ndio behavior of ideal solution in distillation. Ideal solution in distillation tunaziboil, and on a successive boiling at the end of the day tuna end up kwenye jibu ambalo tunakuwa tumelipata kama hivyo hapo. Hii hapa more volatile liquid na appear as distillate and less volatile liquid inabakia as residue. Now let's go to notes and see the explanation for this. We are saying that the behavior of ideal solution on distillation is that the vapor composition of solution is continuously changing compared to its liquid composition on successive distillation and condensation. So by distillating then condensing, condensing, vapor composition ina tend to change. Ina change time to time. Kama nilivyokuambia hapa kwamba tukidraw hii graph unaweza kuona hii graph kwamba vapor composition kwenye distillation ya kwanza ikawa hii hapa. Vapor composition kwenye distillation ya pili ikawa hapa. So tulifanya distillation tukacondense tukapata hii liquid. Tukafanya tena distillation tukapata vapor composition nyingine. So that's the behavior of ideal solution. This makes possible to separate components of ideal solution by fractional distillation. So by definition, fractional distillation is the method of separating liquid mixture whose components have different boiling point. The information whether particular solution of two liquids can be separated by fractional distillation is determined by studying boiling point mole-fraction phase diagram at constant pressure. Boiling point mole-fraction phase diagram at constant pressure inakuwaje? So ideal solution in boiling point mole-fraction phase diagram inakuwa kama hivi. Tunasema kwamba the separation of two liquid mixture is possible when the vapor phase has different composition from that of boiling liquid mixture. So kama unaona hapa kwamba tukiboil liquid hii hapa, hii liquid tukiboil, vapor inakuwa na composition ambayo ni different from the liquid inayoboil. Unaona? Vapor composition yake, hii liquid vapor yake ndio hii. Hii tukicondense tunapata liquid, tukiboil vapor yake inakuwa hii hapa. So composition of vapor inakuwa different from the composition of liquid ambayo tunaboil. Hiyo inaonyesha kwamba kuseparate them by the way of fractional distillation it is possible. So we are saying during distillation, ideal solution boils in such a way that the vapor formed is richer in one component which is more volatile. So on successive distillation and condensation, what will happen at the end of the day, we are saying that pure components which is more volatile is found in the collector as a distillate. Pure component which is more volatile is found in the collector as distillate. Pure component which is less volatile remain in the distillation flask as a residue liquid. So as I drawn the diagram ambayo itakiwa kwenye hiyo space hapo, kuna space hapo chini, diagram hiyo itakiwa iwe ndo kama hii hapa. So tuna boil tunapata vapor, tuna condense tunapata distillate. On successive distillation, kama nilivyoandika hapo mwanzo, on successive distillation and condensation, more volatile liquid will be collected as distillate in the collector, and less volatile liquid will be left as a residue in the distillation flask. That is the behavior of ideal solution on distillation. That is just the summarization of what happens. So we are saying that let me just put well my exercise book. We are saying that upon fractional distillation, vapor formed from ideal solution has a composition richer in a more volatile component. Tumeshaelezea. When this vapor is condensed and distilled again, the subsequent vapor will be even richer in the more volatile component as shown in the figure below. So this graph ndio kama ambayo tumeelezea kule. Tunakuwa tuna certain temperature B, temperature boiling point ya liquid B, then this is for liquid A. So tunakuwa na vapor, tunakuwa na liquid at point P. Tukiboil tunapata vapor at point Q. Tukicondense tunapata liquid at point R. Unaona temperature R hivyo. Then tukiboil ya temperature ya R tunapata S, vapor kwenye S. Vapor kwenye S tukicondense tunapata liquid kwenye N. Ya kwenye N tukiboil tunapata pure component. So hivyo ndivyo ambavyo mambo yanakuwa yanaenda. So repeated evaporation and condensation can completely separate the two component liquid of ideal solution. This is the basis of fractional distillation. A graph that illustrates boiling point composition curve in relation to ideal solution during distillation process is as follows. Even ndivyo ambavyo graph ipo. Na hii graph nimeshaielezea mara nyingi. Ngoja tu tusome explanation za hii graph. Tunasema hivi, explanation of the graph. Tunasema hivi, when a liquid mixture at point P is distilled, and liquid at point P is distilled, that means tukidistill liquid at point P, boil tutapata vapor at point Q. Vapor itakuwa at point Q. Tukicondense tutapata liquid at point R. Kwa hiyo tunachokisema ni kwamba when liquid mixture at point P is distilled at TP, temperature P hii hapa, the vapor pressure Q is formed whose composition or mole fraction of A is greater than that of liquid B. Unaona kwamba tukiangalia hapo kwenye P kuna concentration C2. Kwenye hii concentration C2, A iko kidogo sababu A inaanzia huku ndo 1. A iko kidogo as compared with B. Tukiboil tunapata vapor at point Q ambao A inakuwa imeongezeka. A which is the more volatile liquid inakuwa richer kwenye hii mixture ya Q. Tukicondense tunapata R. So when vapor Q is condensed, the liquid at R which is the same composition as that of Q is formed, which boils at relative lower temperature Tr. So unaona liquid R anapatikana, lakini huyu liquid R anaboil kwenye temperature ambayo ni slightly lower Tr. Tukimboil huyu liquid R tunapata nani? Tunapata S mwenye different composition as compared to R. Na S ameongezeka kwenye A, yani ana A nyingi tukimcompare na nani? Na yule R. So nasema kwamba the mole fraction of A continue to increase at S. Tukiboil R tunapata S. Tukiboil R tunampata S. Na tukimpata S, mole fraction ya hii liquid A inazidi kuincrease. The mole fraction of A continue to increase at S. When the vapor at S is condensed, it is liquid is distilled at N with the temperature Tn. The vapor composition of A continue to increase. Further and finally, pure liquid A is formed on a collector as distillate, and the pure liquid B remain in the distillation flask as residue. Through this process of fractional distillation, pure liquid B and pure liquid A can be separated from the mixture of ideal solution. This marks the end of our session discussing about the behavior of ideal solution on distillation. In the next session, we'll be solving some of the examples using the Roots law, but we'll be solving the examples which will calculate even the partial pressure in the second vapor and the third vapor. Thank you everybody. Don't forget to subscribe to the channel. If you need these notes, you can go to Kipaji app and you can download them. And don't forget to share this video to your fellow students. Thank you, and let me wish you nice studies.